Welcome, children, to our next installment of online lessons in enriched geometry. Your notes should look like this. We are going to go over angle, angle, side, and angle, side, angle congruence. So grab out your notes. It should look like this. And let's get started. Okay, here we are. So again, we are adding to our toolbox of shortcuts, right? So instead of having to show that all 6 parts to 2 different triangles are congruent, we are learning these shortcuts that will make our lives a little bit more efficient and easier than having to show all 6 parts are congruent. So our last lesson, remember we learned side, 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 angle, side. Now today we're going to learn 2 new ones. So without further ado, let's get started. So our first one here is angle, side, angle. Again, math people aren't very original, so the title kind of speaks for itself. We're going to have if 2 angles and the included, let's underline that word again, side of one triangle are congruent to 2 angles and the included side of another triangle, then those 2 triangles are congruent. So we're looking for that angle side angle combination there, all right? So let's see what they have marked out for us. It says we want an angle first, so if I look, I have one archy mark and one archy mark, so I know that angle A is congruent to angle D. And then they want us to give a side, and I look, I have one tick mark and one tick mark there. Box that. So we do know that AB is congruent to DE. And then our last piece that they give us is another angle. B has 2 archy marks and E has 2 archy marks. So then we know that angle B is congruent to angle E. So if we have this type of a situation here in a problem where it's an angle side angle congruence, we can prove that those 2 triangles are congruent. So now we can write triangle ABC. And now remember, match it. What matches A? D matches A. What matches B? E and C and F. Okay? So again, you need 2 angles and the included side to be congruent, and then you have angle, side, angle. So that's our next little shortcut. Our last one here is angle, angle, side. So now let's see what this one looks like. It says if 2 angles and the non-included side of one triangle are congruent to 2 angles and the non-included side of another triangle, then the triangles are congruent. So if you need a refresher, non-included means the side opposite the angles. So the one that's not between the 2 angles, okay? Let's break it down and see what this one looks like. So we want an angle first. So I have an angle A with one archy mark and angle D with one archy mark. So these 2 are congruent. Now I want my other pair of angles. So I have angle B with 2 archy marks, matching angle E with 2 archy marks. And then the last piece they want us to give is our side. So we're looking for our tick mark, which we see is on B, C, and EF. So now with that information, we have an angle, angle, side situation, which is enough to prove that these 2 triangles are congruent. So now we can say triangle ABC is congruent. Now we match, right? So A matches D, B matches E, and again, C matches F. So the 2 new ones today, angle, side, angle, 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 side. Okay. There we are, folks. It says, determine if the triangles can be proven congruent by angle, side, angle, or angle, angle, side. Here we go. We're just going to work our way around the picture. So if I notice here, I have an archy mark and an archy mark, so there's an A. And then I have a tick mark and a tick mark, so that's a side. And that's all I have marked for me. So remember, you can't assume anything unless you know that they're true, always true. And if we notice, remember, we always, those vertical angles, always look for those. If they're ever kind of like intersecting triangles like that, you always have vertical angles. So now I have that angle equal to that angle. So now we do have an angle, angle, side situation. So we're going to say, yes, they're congruent by angle, angle, side. Okay, our next one over here. Again, we do have two triangles that are just butting up next to each other. So if we look here, we have an archy mark and an archy mark, so that'd be an angle. And then two archy marks and two archy marks, so there's another angle. And that's all they give us. But we're smart people. We know that they are sharing that middle side right there, right? So that'd be a tick mark, right? It's on the triangle on the left and the triangle on the right. So now we have angle, side, angle. So that's another heck yes, angle, side, angle. Okay, this next one right here, kind of a lot going on that they have marked for us. Well, we have a right angle and a right angle, and we know that all right angles are congruent, so that's an angle. I have two archy marks and two archy marks, so that's another angle and an angle. And then I have three archy marks and three archy marks, which gives me another pair of angles. So this is interesting. I have angle, angle, angle. Is that a thing? Does that prove that triangles are congruent? And unfortunately, no, it's not. This would be not enough info. They might have sides that are equal, but based on the information they gave us, we can't prove that they're congruent. And now if you're kind of like wondering, well, why I have three pairs of congruent angles, like why is that not enough? Like, I don't get it. Think about it like this. I'm gonna use this space down here. Oh boy. I wish I was better at art, you guys. Okay, let's pretend this is an equilateral triangle. And we know that equilateral triangles have equal angles, right? So if I take 180 divided by 3, I get 60, right? So all my angles are 60. So that's a really small equilateral angle. Let's pretend our sides are like 2. But now let's say I make a bigger that's not equal, equilateral triangle. My angles are still 60, but my sides are now, let's say 7. Are these two triangles the exact same shape? Yes, they are. Didn't fool you there. However, are they the same size? No. So this is actually called similar. They're similar. They're not congruent, but they are similar. We'll get that into that after Christmas. But just know that angle, angle, angle isn't a thing when you're trying to prove triangles are congruent. Okay, back to the next one here. Let's see here. I have a right angle and a right angle, so that's an angle mark. One archy mark and one archy mark. That's another one. And then we notice that they share this side there. So I'm going to put a tick mark. So now we have angle, side, angle. Angle, side, angle. Okay. Cruising right along. Two more. It says determine if the triangles are congruent by side angles. Angle, side, angle, or angle, angle, side. Let's look here. I have one tick mark and one tick mark, so that's a side. Two tick marks and two tick marks. That's another side. Do we know anything else? Nothing else is marked for us. So therefore, honestly, guys, nothing. Not enough info. We're done. Then our last example here. I have an archy mark and an archy mark, a right angle and a right angle, and that's all they have marked. But again, they're not going to trick us because we know that they're sharing this middle side. So it's angle, angle, side. Yes, angle, angle, side. Okay, let's go on to our favorite part, our new favorite thing, which are proofs, right? We are loving the life of proofs. Okay. Again, step one when you have a proof, you're going to read what you're trying to prove. You're going to mark your givens on your picture, and then we're going to go from there. So our end goal is to show that triangle ABC is congruent to triangle EDC. Okay, that seems manageable for us. And now let's mark what they give us, okay? So we're told that angle BAC, so this guy down here, is congruent to triangle DEC. DEC, so that guy gets an arcing mark. So those are equal, my angles. And then we are told that C is the midpoint of AE. Okay, C is the midpoint of AE. So now you gotta think, remember what a midpoint does. A midpoint splits something in half, directly in half, right? Like two equal pieces because it's half, right? So now I know because C is the midpoint of AC, that AC is equal to CE because those are my equal halves. Okay? I hope that when I say things like crazy or weird like that, it makes it stick. I don't know. I'm sorry if that's annoying, but I'm kind of trying to be, if that helps you remember weird things. Okay, so that is what we're given. So right now we have an angle and a side. And we know that's not enough information to figure out if my triangles are congruent. However, remember, we do know some things that don't have to be marked. We do have a pair of vertical angles in here. So now I'm going to have angle, side, angle. Okay. All right. Let's see what this looks like. Okay. So step one, remember, write down your freebies, your free given information. So I'm going to write angle BAC is congruent to angle DEC. Why was I allowed to write that? Because it was free. It was given to me. Next one, write down your next given. So C is the midpoint of AE. Again, why were we allowed to write that? Because it was given. Okay, so now what did we do because we knew C was the midpoint? Like what information was now made sense to us because C was the midpoint? We marked that AC is congruent to CE because C was the midpoint. The reason for that, guys, it's really, don't make it more complicated than it is. It's literally just definition of a midpoint. By definition, a midpoint splits something in half, and that's what we use to show that AC is congruent to CE. Definition of a midpoint. The last thing that we had to figure out on our own was we had vertical angles, right? So I'm gonna write vertical angles. Now, what are those vertical angles? You have to use three letters, right? Because there's multiple angles happening at C, and I can't say angle C is equal to angle C. So you have to use three letters. So angle, like BCA, is congruent, I'll trace it out, to angle DCE. Those are our vertical angles. And then, folks, our last step is always what we're trying to prove. So we were trying to prove that triangle ABC is congruent to triangle EDC. Why did we write that? Why is that true? Well, look, folks, angle, side, angle. And that is it. How do we feel? Sometimes I wish I could see your face, but sometimes I'm thankful that I can't. So I wonder how this is going for you. Okay, let's do this last one together, and then we'll have some more work time in class, just kind of crank out a bunch of other examples, all right? So again, our end goal is to show that triangle WYZ is congruent to triangle XYZ. Okay, I think we can handle that. Let's see what they give us. It says YZ bisects angle Y. Sorry, you guys, my brain just went blank. Okay, one more time. YZ bisects angle WYX. Bisects. Bisects. What does bisect mean? It means to cut in half, right? So we're cutting this angle here in half. So now I know that this angle is congruent to this angle. Okay, that's one thing we know. Our next thing they tell us is angle YWZ is congruent to angle YXZ. So we're going to put 2 archy marks there. So that's all of our freebies. And now we got to look to see if we can come up with something on our own. And we've seen this multiple times by now, right? That they're sharing this side in the middle. That's our reflexive property. So now if we go around, we have an angle and a side, which is enough information to show that those triangles are congruent. So let's write it out. Again, you start with your freebies. So write YZ bisects angle WYX. Why did we write that? Because it was given to us. Now here, your proofs don't always have to go in the same order. Like you don't have to write your next given right away. You definitely could. But sometimes I get a little, I don't know, I have my issues. And I'm going to say, well, what happened because YZ bisect the angle WYX? Well, we marked that angle WYZ is congruent to angle XYZ. So I'm going to write that next, actually. I'm not going to write my next given. I'm going to write WYZ is congruent to angle XYZ because that was a result of YZ bisecting that angle. And then my reason, I think, kind of comes more similar now. Why did I write that? Well, I wrote that because definition of a bisector. Definition of an angle bisector. Okay. Now my next piece, I'm going to write that other given. So angle YWZ is congruent to angle YXZ. Why? It was given, it was free. And now the only thing that we had to come up with on our own was the reflexive property, right? They shared that middle side. So I can say YZ is congruent to YZ by what property? The reflexive property. So now we have justified why triangle WYZ is congruent to triangle XYZ by angle side. Okay, now again, folks, just I want to reiterate, you can definitely flip 2 and 3 around. You can write your given, since that's what I've said since, I don't know, 2 days ago, that you can write your givens right away first. That if that's what you like doing, totally do that. I just, sometimes it's easier for me to write it like this. So know that there's more than one way to write it, and however your brain works for you. That's amazing and that's great. But just know that you can kind of switch it up a little bit if you need to. As always, thanks for watching and putting up with my shenanigans and things like that. I hope you're having a fabulous night, day, whatever time you're tuning in. And I will see you when I see you. Adios, amigos.